Hello, my name is Walt Schoenborn, Senior Strategy Consultant with SafeLiShare. Today we're excited to have Ann Anderson and Shamim Naqvi join us to talk about how we can use SafeLiShare Confidential Cleanroom for your AI machine learning workloads in healthcare. Ann Anderson, Executive Director of ML Engineering and SafeLiShare Strategic Advisor, who will share insights into the current machine learning and AI practices and security measures in healthcare. Additionally, we have Shamim, CEO and co-founder from SafeLiShare, to shed light on the recently launched secure enclave-based SafeLiShare Confidential Cleanroom. And Shamim, welcome. Shamim, my first questions are directed for you. Could you provide an overview of the recently launched SafeLiShare Confidential Cleanroom and its significance in enhancing data security using secure enclaves?
Well, the notion of clean rooms is very old. So, for example, the computer fabrication business, the notion of a clean room refers to physical rooms where fabrication happens. In the pharmaceutical industry, the notion of clean rooms are physical rooms that provide a contamination-free environment for drug research, etc. The notion of data clean rooms is also not new. There are several companies that provide a notion where first-party data can be combined from two or more parties together under a set of trusted guidelines provided by the service provider. What is new in the SafeLiShare case is that there is no trusted party in the middle, and where the rooms come with the guarantee from the underlying hardware instances which are used. So it is truly a zero trust environment. There is no service provider, and the collaborations happen because the underlying computational fabric itself provides the trust guarantees. So no trusted party in the middle. The rooms are isolated and protected computing environments, and the guarantees come from the underlying hardware. That is the essence of the SafeLiShare clean room solution.
And if you could speak to a little bit on the SafeLiShare clean room integration with machine learning and AI processes, especially as it applies to healthcare.
Sure. Healthcare, our top priority is always to protect the privacy of customers. That is the most important aspect. In addition to that, we also need speed to send information back and forth quickly to serve our customer as best we can. So data streaming is very important in that regard. For instance, imagine that you go to the doctor's and you need a prescription filled. Then you go immediately to your pharmacy, but the prescription hasn't arrived yet at your pharmacy. That's a point of frustration. So given the massive amount of data, the complexities of all integration pipelines, and the speed with which our customers require that data to be sent from point A to point B to point C, we think that there could be a great deal of benefit with respect to the use of clean rooms over the complex integration pipelines that we have currently.
Thank you, Ann. In regards to that, I wanted to get into a little bit regarding compliances. And this is really directed to both yourself and to Shamim. In the context of healthcare, how does the SafeLiShare clean room, and this is really more on the aspect of directing towards Shamim, but how does the SafeLiShare clean room ensure PII and GDPR compliance with relevant regulations and standards?
Yeah, so we should be careful. Secure enclave technology, which is the basis of the SafeLiShare clean room and certain other solutions as well, is a tool. It's a technology tool. But the aspect of machine learning and of compliance, etc., has to be added to the notion of secure enclave. So we need certain types of abstractions that allow compliance for compliance to happen properly. In the case of SafeLiShare clean rooms, we have patent pending technologies in which privacy and confidentiality filters are brought into the clean room. And these provide facilities that are specific to GDPR compliance, HIPAA compliance, etc. So these kinds of technologies are added on to the basic underlying technology provided by secure enclaves. But these are abstractions that are provided for compliance reasons. It turns out HIPAA and compliance and GDPR compliance are two forms of compliances, but there could be many other financial regulations, etc., and consumer privacy, etc., are all particular types of compliance requirements that need to be satisfied. And this notion of having certain kinds of privacy and confidentiality filters, we believe sets up the SafeLiShare clean rooms a step above and a step apart from other such implementations.
Thank you. And I have a question for you regarding implementation. Regarding machine learning and AI within healthcare itself, where do you see the necessity and the efficiencies based for healthcare companies to be implementing clean rooms?
Well, with respect to AI and ML and clean rooms in the healthcare industry, again, the importance is protecting the privacy of the customers and upholding all the regulatory requirements. So the usage of machine learning can be deployed in many ways to support that, along with the clean rooms. So let me give you a couple of examples. One of the examples that we can provide is scanning and understanding what the pattern of behavior is by a certain set of users. And if the pattern is deviated by a user, then we can detect that as an anomaly. And that can be done through the audit logs, or it can be done through other actions that take place based upon events. So that would be an example of how machine learning can be used to detect anomalies, which then can help to protect the privacy of end users. Another way that machine learning can be used is to determine the pattern of behavior of infrastructure or systems themselves, to understand when there might be a failure that would be impending in the future, and to detect that and prevent it before there's an actual outage. And in that case, if there were to be an outage, that could impact the speed with which a person, like in the previous example, might get their prescription filled. So in order to make the infrastructure, the systems, and the deployments more secure and more resilient, we can use machine learning in that way as well.
Going into that a little bit more, I wanted to ask you some questions that you look at for challenges on security and maybe how some of those challenges are being currently addressed.
So security, there can be external threats or internal threats. So working to understand, again, what the patterns of behavior are and identifying anomalies using the machine learning can help to prevent internal threats as well as external threats. They're very different. Also, using machine learning to scan various vulnerabilities in software levels or other actions is something else we can do.
Great, thank you. Shamim, I was wondering if I could come back to you for a second. I wanted to talk about SafeLiShare's confidential clean room specifically, and wanted to ask you more about scalability and flexibility. Can you elaborate a little bit on both those items, the scalability and flexibility of the SafeLiShare clean room, particularly in handling machine learning and AI?
Well, yes, the notion of clean rooms is that there isn't a single clean room for all computations. In fact, one should think of a collection of clean rooms and a pipeline of computations that are supported by having a notion of a set of clean rooms that are interconnected. And the computation proceeds from one room to the other through secure connections between the interlinked communities. So just like any other pipeline architecture, there is a pipeline architecture of clean rooms as well. So that is how scalability is achieved.
And in regards to that and the scalability and flexibility, I wanted to ask you really what distinguishes SafeLiShare's clean room and sets it apart from other clean rooms that are currently in the industry.
Well, as I said before, a number of clean rooms offered by certain firms require the service provider to be a party to the trust model. In the case of SafeLiShare, that is not the case. It is a platform, not a service. So SafeLiShare provides a platform to the collaborating partners. And the trust equation at that point does not involve SafeLiShare. So that is the first point of difference. The second point of difference is that the trust mechanism is not a set of rules that the service provider satisfies. It's the underlying hardware that provides the isolation and the protection. Another point to be made is that these abstractions that are provided by the underlying technology depend on the manufacturer. So when you go to a secure enclave on a certain cloud system, you get a trust model, but that trust model is based on the hardware provided by that cloud provider. When you go to a different cloud provider, the trust model is different. So the abstractions that SafeLiShare provides hides the differences in the trust models across different clouds and across different technologies. There are several providers and manufacturers of these secure enclave technologies. SafeLiShare hides all those under a common set of abstractions, provides a single unified trust model, and hands off that trust model to the platform operator so that the host organization and its partners can participate in the trust mechanism instead of having a service provider in the middle. So those are some of the differences between the SafeLiShare implementation of clean rooms and others.
I wanted to speak and have you speak a little bit to SafeLiShare's confidential clean room in its regard to runtime and model identity and patterns, if you can, please.
Yes. So one of the main reasons why the notion of clean rooms seems particularly useful for machine learning is that there are lots and lots of machine learning models being built today. And there are, at the same time, lots of companies that want to use machine learning models. So there is a pent-up demand where a lot of data owners realize that they're sitting on lots of data and they want to do analytics on the data, but they don't have the models to run on those data. Hence there is a demand for model sharing to happen. The notion of clean rooms is a very interesting and useful way for models to be shared with data owners. And there is a catchy phrase that we sometimes use. It's called bring compute to the data. So the data doesn't move, but the model comes to where the data is. So you can now imagine that a data owner can have a clean room into which a shared model is sort of injected, and that model runs on the data owner's data and provides the results to the data owner. The issue at hand is that anybody who provides a model into this clean room would want the IP of the model to be protected. And we call that model confidentiality or model identity confidentiality. So one way to do that is to encrypt the model before you inject it into the clean room. And the clean room provides an isolated and protected environment under which the model is then decrypted and run against the data in the clean room. And the results are then, in fact, encrypted and given out to the data owner. When you decrypt the model inside the clean room, there is a threat vector that says somebody at runtime can now look at what the model is trying to do. The model itself could be malicious, by the way, also. Right. So there are multiple threats here at this point. So this is where the notion of privacy filters comes in, which is a patent pending technology that SafeLiShare has. One way to do this is that when you decrypt the model, you take a hash image of the model and you test it against a previously known curated version of the model to know that there is no malware in that model. Number two, the isolation and protection of the clean room guarantee that when the notion is decrypted, there is a notion of runtime security that is in fact implemented by the secure enclave technology, which is used by the clean room. So no other access is allowed into the clean room other than the model and the data. And there is no other entity with that can access this particular notion of runtime. So everything is encrypted outside the clean room. The decryptions happen only inside the clean room, where the isolation boundaries of the clean room protect decrypted runtime environment. And every result computed inside the clean room is then further encrypted before it leaves the clean room. So that is how one notion there. The other notion where you can detect patterns of attacks, etc. So for example, there is a lot of literature now on machine learning adversarial attacks. These are inputs which look at the behavior of the model and try to infer certain workings of the model that can be detected by the patterns of the input. And again, this notion of filtering the input and filtering the output, etc., can be great tools to use with machine learning workloads. I think the use of clean rooms for machine learning use cases is particularly apt and could be very fruitful and a game changer, because the notion of sharing and collaborating in machine learning is such a crucial function. No one has all the data that they need, and no one has all the models that they need. Right. So there is a pent-up demand for sharing. And this is, in fact, why some of the healthcare companies are at the forefront of data and model collaboration exercises.
And cannot stress the importance, especially when you have multi-party collaboration within the clean room, how important that encryption model is for, chain of custody, for things like that.
Yeah, there is a notion. I was speaking with a colleague a few days ago, and he used a phrase. He sees a great use of clean rooms in what he referred to as double-blind identity matching, which is his way of saying, in the healthcare arena, one of the holy grails has been is to take patient data from two different sources and create a longitudinal record of the patient from such disparate data sets. And one way to do that is this double-blind identity matching notion.
Well, that's fascinating, and I wanted to go ahead and, on that note, sign off from this presentation. I wanted to thank Ann Anderson. I wanted to thank yourself, Shamim, for joining today. And it was great to be able to speak a little bit more towards SafeLiShare's confidential clean rooms. Thank you very much, everyone.
Thank you all for having us. Thank you so much.
Thank you. Thank you for having me. Thank you.